Okay, so today we're going to be fixing a Mazda 3 2007 horn. I've done some debugging. I know the problem isn't with the relay. I know the problem isn't with the horn. I've bought a new horn module. And I know the problem isn't from relay to steering wheel. The problem is actually with the wire that is south of the relay. So this wire here was completely corroded at the end where it connects to the horn. And it's corroded and shorted somewhere farther up the line. So taking a wire and actually shorting the horn power causes a smoke smell. So there's definitely some shorting somewhere in here, which I don't want to be repeatedly causing. So I'm going to quickly show you guys that the relay itself is fine by just putting in the relay, clicking the lock button, and we can hear the actual click. So that clicking there is what you're looking for. And you can do the same test with the actual horn itself and either have somebody else listen or just listen very carefully. If you press the horn on the steering wheel, you should hear the click as well. I'm going to take the relay out. No click. So we know the relay is triggering fine. You can check on the actual fuse board. It says horn here. It also says horn up here. So just make sure that this fuse isn't blown, but in my case it isn't, and the relay itself is fine. So I'm going to be showing you guys how to build a pigtail extension for the relay port and how to wire your own wire down to the horn. Okay, so these are all the parts that you're going to need for this. I know it might look a little intimidating, but it's really not. So in total, everything on Amazon cost me about 150 Canadian. And you can find absolutely everything on Amazon. Everything here except my multimeter was single day delivery. Also the tools here. So yeah, in total what you're going to need is some 14 gauge wire. This is what you're actually going to run to the horn from the relay pigtail. You're going to need the heat shrink spade connectors. These are what are going to actually slot into the fuse box, or the relay box rather, in place of these relay pins or little slots. Oops. You're going to need the O-ring, ring terminal connectors. These guys are if you need to connect directly to the battery. We'll see if in my case I need to, but might not. And then we have the heat gun and the shrink wrap kit. This is just in case we have ends that aren't terminated with these heat shrinks. And then we have the ratcheting crimper. This was like 40 bucks on Amazon. The actual pigtail relay extension, you can search up just relay extension, Automotive, or something like that, comes with the relay. I got 2 sets of these for I think 26 bucks, so they're relatively cheap. This is just a generic 4-pin fuse, or sorry, relay, 12 volts, 40 amps, and then this is the extension. So these two plug into each other like this. Oh, like this. So there it is. So this will function in place of our existing relay. I couldn't find any pigtail extension for this shape of relay, so it's easier to just get a new relay that does the same thing, same voltage, and then just using whatever they sell. So we're going to start by wiring all the spade connectors correctly to this, and we'll go over what you need to connect to where. Okay, so before starting on actually wiring up the circuit, we want to understand our relays. So this is the old relay here. There's nothing wrong with it, but again, I just couldn't get the pigtail extension that fit this 4-pin configuration. I believe this is called a mini relay. There's a micro, or sorry, these are the micros, these are the mini 4 pins. There's 5 pins as well, but for this relay itself, on the underside of it, there are tiny, tiny labels that you're going to be hard pressed to see, especially, and it's impossible on the video, I'd say, but I'll read them out for you guys. This one here, this bronze one, is COM. This is NO, which stands for normally open. So that's our actual switch that by default is open, which means that by default the circuit is open and therefore broken. And then we have our 2 silver ones. These are both labeled coil. So these are what go to our steering wheel horn. When you press that, that completes this circuit. And then when this relay is flipped and triggered, then these two connect, and then it completes the actual horn module to battery circuit and sounds the horn. So for these 2 ports, technically this relay is non-polar, but there still is a positive and a negative. Battery power comes out of the positive and returns to ground through the negative. So we're going to actually probe our relay slots outside in a bit, and we're going to check. One of these will be 12 volts when connected to ground. One of these will be 0 volts when connected to ground. One of these will be 0 volts when connected to ground. That will be our normally open. And one of these will be 12 volts or 13 volts roughly when connected to ground. And that's going to be the one connected to the battery. So this is our old relay. The new relay is a JD1912 12 volt 40 amps. It's got at the front a little diagram that you're not going to be able to see, but I'll read it out. It says 8586 is the actual relay itself. Then we've got a little open circuit symbol, like a little slanted relay. That is labeled 30 and 87. So these correspond to coil, coil. Then we've got our normally open and our COM port essentially. And these are all labeled as well on the bottom next to each of these pins in tiny little numbering. So going online, we can actually see the diagram itself here, and we'll just make some notes. So searching out JD1912 on Amazon gives us this diagram. And in the diagram, we can see 30 and 86 are connected to our battery. So when we go out to the relay, that's going to be our coil. And then this is going to be our coil return. This is going to be our COM, and this is going to be our NO. So let's actually make note here and plug in the actual relay to the pigtails and just label the colors. So this will only plug it in one orientation. We've got the horizontal one is 87, 86, 85 are beside each other, and then 30 is at the bottom. So for our case, we have 30, which is the blue. Then we've got 87 up at the top. And then we've got 86 and 85, which are our black, or sorry, our white and our black and our white respectively. So I'm just going to write this down. So checking again, one sec. 30 is blue, and then we'll just go clockwise from there. So switching back, 30 is blue, and that corresponds to our COM port. 86 is, just checking again, 86 is white. 86 is white, and that responds to our coil positive / live. And then we have our 87. So this is across from our blue, that's our red. This is going to correspond to our NO, or sorry, yeah, our NO port. And then we have our 85, which is our last one, which is black. And this corresponds to the coil ground. Okay, so now that we actually have this, we understand what each of these correspond to and how they work. We're going to switch back to here, and we're going to start getting these spade connectors crimped onto the actual pigtails themselves. Our 87, which is the equivalent to our NO port, this we're going to want to leave open and maybe do an inline crimp to the actual 14 gauge wire that we're going to run to the horn itself, because you know, we don't want to be putting a spade connector on that. We got to run wire all the way to the horn. But for everything else, including the ground, we could connect it to the negative of the battery, but we'd be better to connect it to the relay ground, unless there's something wrong with the relay ground, which we can find out. I don't think there is, but there might be. So yeah. Okay, so I've got the spade connectors on everything but the red. The black one might need to come off. We can just cut the wire and crimp on an inline connector. This might have to end up going to our battery negative instead of going to the relay ground, depending on if the relay ground is broken, but I don't believe it is. We could hear the relay switching, so I don't believe it is, but it might be. So we're going to get our crimping tool, ratchet and crimping tool, and we're going to line up to the blue, which is the middle one. Line this up in here and just crimp that down. Okay, so we are crimped and heat shrunk on all of these. I just use my little heat gun here. Like this, and like that until they all shrunk. So now you can give them a better tug, and they're on there pretty solid for both the crimp and the heat shrink. We're now going to want to connect some of the 14 to 16 gauge wire. There's copper clad aluminum, and copper, or tinned copper, I believe. Tinned is better. It's just more standard for regular automotive. The copper clad aluminum is slightly more resistant. but it's not a huge deal. So for long runs, you want tinned. I've got about 5 feet or 6 feet of this line here. I'm going to connect the two. Okay, so what's awesome about this little set that I bought is that these guys are both heat shrink. You can see this little metal bit in the center. This is crimping and heat shrink on either side. So you feed both of the wires in, you crimp in the center, and then you heat shrink on the outside, and that really locks the two together. So just push those two through. Then we're going to give it a bit of a twist, and finally we're going to crimp it. Okay, so we're now going to be testing the actual relay ports themselves. So one of these, which should be our coil, and our coil, our COM, which is this bottom one here, then our NO, which is this middle one. So coil, coil, NO, COM. To ground, over here, we get 12 volts out of this coil port, so that is our live coil. Then we've got our other coil port, that should be 0, beautiful. Switching over to our NO, normally open, we should expect 0, beautiful. And at our COM, we should expect 12 volts. Okay, so going back to the actual relay itself, the new wiring, we know that our NO is going to go down to our horn. We know that our blue is our COM port, our white is our positive, and our black is our negative. So let's get that all wired in just to test. So there's our black, that's our ground. Our white is going to be our positive. Beautiful. And then blue is going to be COM. And so we don't have anything wired. We don't have anything wired into the actual NO port because the NO is coming out of the relay here. And we're going to connect this down to the horn itself, which I have right here. Okay, so with everything hooked up, we've got the white to the positive coil. We've got the black to the ground. We've got blue to COM. We've got red to the horn itself. We've confirmed that the ground is okay. We're gonna press the horn and we get the honk. So horn is good now. We just gotta hide this wire and clean up this loose end. But I guess it's actually technically disconnected, so we don't need to worry about it. Okay guys, so we got everything closed back up. Listening to this. We've got the relay out here bolted into there. I'm gonna get some hot glue and I'll seal up in there just to be safe. You don't want any water getting in there, but fuse box is closed up. We got the wire running out through here. Can't really see it, but there it is coming out. It's running down through here directly to the horn, and there's some zip ties along the way just to seal them up. Yeah. We're good. So yeah, that's how you make your own circuit for busted fuse line. Just run 14 gauge wire, get an external extension for your relay, and just know where to wire it. Thanks so much for watching. I hope the video was helpful and was informative. If you have any questions, feel free to ask them in the comments. I'll try and answer them. And if you found this video helpful genuinely, make sure to like, because there are likely other people who run into the same problem who need help, and this will help them find the video easier. So, thank you.